Well, hello guys, welcome back to John's Workshop, and in this video we're going to be doing workshop tips number 5. And as you can see on the board behind me, this is reverse engineering, or at least that's what we're calling it. It's the closest to reverse engineering that we're probably going to get out of this workshop. So why am I doing this? It's kind of born out of necessity. I've got a couple of things that I need to do, so one of them being my shaper. If you've been following that refurb series of videos, you'll have seen when I took the motor mount bracket off the back of the machine, it's in far more pieces than it should be in, so we need to do something about that. And as I said in the video, it's beyond my skills, capability and equipment to try and do anything with that, to try and fix that, so we're just going to make a new one and make it look as close to the original as possible. Also, I've got my engraving machine here. Again, there's been a series of refurb videos on that. I want to measure the collet up in the spindle, both for my own purposes and also for one of my subscribers that's got the same machine, and he's asked if I could get him some data around the collet so that he can probably make himself some collets as well. So 2 parts, and we're going to go to the surface table just shortly and get into the reverse engineering sort of procedure of how we're going to attack both those parts. Now, what's important with reverse engineering, it's not just about measuring something up. You've got to have various thought trains on the go at the same time, and you need to be thinking about, what you're going to make the part out of, how you're going to make it, how you're going to hold it, where you're going to datum it. You've got to also think, if it's a part that sits in an assembly, what does it make with? Which surfaces are important, which surfaces aren't important, which are the dimensions that really matter, which ones don't. Because obviously without a drawing or a print, you've got no tolerancing information, you've got no datum information, so you need to be thinking about all of that stuff. It's no good just going and measuring a load of nominal dimensions as you measure it and trying to make to that. You've got to be thinking about how it all fits and knits together with whatever it fits to, and which surfaces you need to pay more care and attention to based on tolerances, limits, fits, all that kind of thing. So quite a complex thing really to get right, and I'm no expert at it. I've done bits of it in the past. The experts at this are the Chinese, absolutely. They've spent the last 25 years perfecting the art. They can take the most complex thing apart into tiny pieces and successfully make something that resembles the original component or the original whatever it is, the original item. And machine tools is one thing I've seen firsthand actually done, and they're very good at it. They can copy almost anything and make something that looks and behaves almost like the original. So we're not typically that good at that in more in the sort of Western world. We typically work from prints, drawings, things like that, and that's what we're used to. So this is a little bit out of our comfort zone, so I thought I'd put a video out on it. I've got to do it anyway for my own purposes, so I'd make a video on it, and hopefully there'll be a few hints and tips along the way for anybody else who might be faced with a similar situation. So I'll join you very shortly at the surface table and we'll dig in. So we're at the surface plate. We've cleaned the surface plate off and we've got our broken bracket cleaned up, so we've taken all the muck off it and grease, and in doing so I think we can find the evidence as to why the bracket's broken. So I don't know if you can notice this piece of studding here, or this bolt, but it's bent like a banana and it's been mullered here by the looks of it where the nuts have been. So my guess is that's been thumped at some point at the back. It's bent the bracket, it's distorted the threads, maybe, all guesswork, but so yeah, that's probably why the bracket's broken. So the first job I've got to do is probably hacksaw through this, because I'm not going to get these nuts past this dodgy thread. So we'll get this extracted from the bracket and I'll bring you back. Okay, so we've got our bent stud out of there now. So as I said at the start of the video, a few thought streams are all on the go at once here. So when I'm looking at remaking this thing, I've got to think about how and what I'm going to make it from. So I could machine this from solid if I had a big lump of steel, but that would be incredibly wasteful and I wouldn't be doing that. So really the most sensible way of making this is to fabricate it. So when I'm thinking about fabrication, I'm just looking at the thickness of these side wings, and the bottom all looks to be roughly the same thickness. So one bit of bar stock of the right thickness, I would be able to get this base piece out and the two side pieces, no problem at all, and then weld probably into the corners here where there's fillets in the casting already, so that would be okay. And there is this, obviously this lug here, which would need to be a further fabrication if that was the case, of something else that I put on and weld on top of it. And again, there's fillet weld round all the way round, with the only bit missing here, clearance for the bolt head. So the reason I pointed this out in my recent video, I'm not going to try and repair this. If you look at the casting itself and you look at the intricacies of where it's actually broken through that bolt hole and round that lug, and also there's further cracks down the other side of this lug here, I am just not confident enough, and I don't think I've got the right gear, and certainly don't have the right experience to even attack that and hope to get a decent result out of it. So for me, what I do know will work is a fabrication, so that's why we're going that route. So now we know roughly how we're going to remake this thing. I now need to start thinking about, as I said at the start, what's really important and what's not before I start measuring. So there's a machine face at the back, where we attach to the machine. There's these two holes that are machined, which are just clearance on some bolts, and then there's some counter faces, if you want to call them that, for the bolt heads to fit on into the casting. There's this hole here that's machined, and there's the main pinion hole here that's machined. The rest of it really doesn't matter too much at all. There's some clearance probably around these lugs that I need to think about. So the main important features are those ones that have been machined that I've just spoken about. So I'm going to have one mind on those features when I start measuring, in terms of where I measure them in relation to, so that I then understand where I think the best place to strike a datum from is on this when I start drawing it up, so that I've then got something to follow in manufacture. Now there's lots of ways I could do this. I could measure, and I probably will do, just to show some different ways of doing it. I could measure these angles, and they're tapered as well, so you know that's quite complex geometry to try and measure that up, especially on cast surfaces. What I'm actually going to do is, once I've got my steel bar, I've got a perfect template here. I'm just going to lay this on top of the steel bar and actually, you know, mark out around it and make it to the scribe lines, because at the end of the day it's just a casting, and that will get me, because I've got this datum face at the back, that will get me the angle correct, this tapered wedge shape, and the angles correct to that back face. So that's actually the easiest way of doing that, and that's how I'm going to do it. So I don't really need to worry myself too much about these angles and the wedge shape and all the rest of it, because I'm just going to trace it. I'm going to trace around the existing part, so nice and easy. So what I'm going to do now is we're going to get some measurement gear out and a pencil and paper, and we're going to start thinking about taking some dimensions off this. So the first thing I want to know is what stock sizes I need to buy. So I've done a sketch, called it stock, and I've drawn basically what I'm seeing from the front here, looking on the part this way, and from that view I can get my stock thickness for the base plate, stock thickness for the two wings, and stock thickness for this raised portion here in the centre. So I'm going to crack on and measure those up and stick the dimensions on the bit of paper. So I know now my stock thicknesses. I'm converting really from, I'm going to do all this in metric just for ease. So I'm going for metric. So what our thought process I've got in mind now is I'm looking at the design of this and looking at the closest metric stock sizes that I think will be adequate without losing any strength or making this shape any particular different from what it was originally, to try and, I've got a thought process going around cost now and around time and effort to make. So these webs were slightly thinner than 10mm. This base section was slightly thicker than 10mm, and so I'm rounding this down to 10mm for both bits, and I don't intend doing any machining. I'm just going to go straight for 10mm for all of it, and if I find that I'm too thin between these two wings, I can just machine the right amount of clearance on the inside faces so that whatever fits in between that fits in without any bother. So that's what we're going to do. And again, if I go for standard stock sizes as opposed to oddball sizes, the cost of the raw materials is going to be much cheaper, as I don't think I've got anything in the shop that's going to do this, so I'm going to need to order some steel in, which is the whole reason that I'm in this position of needing to do the measure up. So I'm now going to cut the camera, do another couple of sketches. I'm going to take a few more dimensions, and if there's anything interesting I'll bring you back and show you what I'm measuring up, how I'm measuring it, why it's important. So as I said earlier, I've drawn a side elevation now, and I've worked out where my two datums are going to be. So I'm using sort of proper drawing symbols for the datums, but this is just a sketch. So there's going to be dimension lines crossing each other and all sorts. It's just a sketch for me to make it. But so I've got my datum A, which is the back face that's machined, and I've chosen, of the two cast faces, top and bottom of this back piece, I've chosen the top face because that's the cleanest on the casting and the straightest looking. So we've taken that as datum B, and now what I'm trying to find out is, as I said earlier, what's really important is where's this hole in relation to both of those two datums, so that I can replicate that in the finished part. Several ways you can do this depending on what kit you've got. So I've put a piece of ground drill rod through the two holes. It's not the best fit, it's slightly baggy, but it's close enough. And I've got a slip pile here that I've worked up to get me to the right size. So I'm just using the clock as a comparator. So I've zeroed out on the slip pile there, and then if I come in onto the pin, I'm reading 0 at that end on the clock, and at the other end I'm reading about 3 thou, so 75 microns less than 0, but that's the end where the crack is. So I'm less inclined to believe that end than I am this end. So we're going to take the reading from this end as my distance away from the datum face to the top of that diameter piece, and then obviously I need to minus the radius of that pin off to get me onto centre line. So I'm just going to do all that off camera, make my sketch right with a dimension, and then we'll think about how we measure the other direction from the other datum face to the same hole centre. So we're just the other way up, same idea. I've got my slip pile, 0 the clock, and I've got that set up so I'm reading 0 on the pin. I know you can't see it, but so I just want to point out, you know, this is a little bit overkill. In fact, it's a lot overkill for a casting, but this video is not about this casting particularly, it's about reverse engineering. This could be something much more accurate. So I just wanted to point out a way of doing it. That's there's you know, lots of other ways for the casting. Really, a transfer punch, laying the old pattern over the new pattern when I make them, is going to be more than good enough for what this is potentially. You know, if you don't have a surface table, a surface plate, but you've got a machine table, you could quite happily use your machine table to do a similar sort of check. If you don't have, you know, a ground bar, you could use a drill, as long as it's a good fit through the hole. If you don't have a clock and slips, you could try using verniers to try and measure various different bits using a vernier. You know, there's lots of different ways you can get this. I'm just showing one way here, and I'm doing it this way because largely it's, you know, I've got the gear and it's pretty easy and quick to do, but I wanted to show it because this, you know, if you're reverse engineering something much more accurate, this is probably the way you'd go about it. This way I would, you know, if I was doing the way I'm going to actually manufacture these brackets, I would just spot the holes through onto the new ones once I've made them, but we'll do it this way for the video. So I'm going to carry on taking some more measurements, drafting up, and then I'll bring you back when all that's done. Okay, so I've got the rest of the dimensions done, largely two sketches with different sections. I mean, this is really scruffy and scrappy. This is how I would normally do something like this, and then I would go and transpose all of this onto a better drawing if it was going to be going for someone else to make, or if it was something a little bit more technical, a bit more involved. I'm not going to do that for this. I've got everything I need on here. I've got the part to refer back to should anything be confusing when I come to make it. So I've got enough dimensions to order the raw material. I know what I need. So yeah, as I say, I've just done the rest of the measurements with a vernier, the ones that don't matter so much, and a couple of cutaway sections here showing the boss sort of area. And then it's not really for sketch drawings like this, but if you look at right over here, this is the only tolerance I've put on it, and I've said that this hole needs to be, this hole that goes all the way through both lugs needs to be parallel to datum face A across the back within 0.1 of a millimetre, 4th thou. More than easy to do that on the mill when I come to machine this. So yeah, you don't need to see all the dimensions. That's not this isn't a how to make this bracket video. This is a how to do reverse engineering, and I think I've covered most of the kind of thought. It's the thought process that's important here about what are the things you need to think about, and I've covered a lot of that off on this part. So next part is to go and get the small collet out the engraving machine, come back to the table, and we'll set that up and start doing a very similar thing to this, i.e. a rough scratch pad sketch. But for the collet, because that is going to go to somebody else, I shall then transpose that into a proper manufacturing drawing for somebody else to refer to. So bring you back just shortly when we're doing that. Okay, so we've got our collet out of the engraving machine. It's a very oddball looking collet, as you can see. It's not an ER collet. It's very similar to an ER collet, but it's got this lip on the front edge here, and then it's got the groove in there to fasten in through the clamp nut, if you like. It's got 4 slots that run out pretty much at this bottom, where this bottom step is here, and so all the spring is generated through this thin ring at the back. It's opened out inside so far back it's relieved, which will be to create the spring, to control the spring on the collet. And unlike the last part that you've seen me staring at, this is completely the opposite end of the spectrum. Every single dimension on this really is critical, probably with the exception of, well, they're all critical. This diameter on the back, it doesn't do any location from a clamping perspective, but that will be controlling the amount of spring in the collet, so again, critical. Yeah, there's not really a dimension in here that's not critical. Even the bottom of this groove here will be fairly critical to fit through the nut, so there's not a single dimension on there that's not super critical really for good run out. So what we've got is a 4mm piece of gauge rod. I realise that's upside down, but that says 4.0, and we've got, you know, you should never measure anything like this in a relaxed state because you will get really cronky measurements. It needs to be properly expanded out onto the size that it's meant to grip. So we've got that on this bit of ground drill rod, and we've had it set up on V-blocks. I'm not going to go through all the dimensions, but I'm just going to go through some of the dimensions that I've taken on this. Now there's not so much thought process on this because every dimension's critical. Largely you've got to measure as best as you can and as tight as you can on everything. So what we've done is we've sat it between the V-blocks. I know I'm lined up because I've pressed in on that 4mm shaft, so I know these V-blocks are aligned, and I've crunched those V-blocks up until there's no slack on the part, so it's not moving in between, laterally in between the V-blocks, therefore it can't move, but it can rotate. I've used my DTI at several places and I've just messed it all up, typical. I'm just going to show you how I've been doing it. I've used my DTI at several places on the OD of the taper, and that's why it's important this thing can't move side to side, obviously because it's on a taper, and I've been rotating the whole thing, checking concentricity of the external taper, which is the important bit, to the internal bore, because they're the two most important dimensions that have to be concentric. If that wasn't concentric, then there wasn't a lot of point me measuring anything else up at that point, because the dimensions would be meaningless. Fortunately, concentric everywhere along that taper, so was happy with that. And then largely I've been using a various different measurement equipment, so I've been using a 0 to 25 for the diameters that I can get on, so the back diameter, this front diameter, the crown diameter on the top here. I've used a bore mic, Moore and Wright bore mic, which is a ball mic, to measure the relief diameter in the back, so that's what's been used to go in there. I've used a blade mic to measure in the groove here to get the measurements, and with this it's a case of taking lots of measurements all the way around, and you know, with all these measurements, because this is a split collet, you need to be taking an average of all the dimensions as you measure, so that's what we've used for that. The only thing I've got is a set of feeler gauges to measure the actual slots in the collet, so I've got a really good feel on these. These are imperial, so I'm going to have to convert that measurement into metric, but I'm getting 26.5 thou, and I've got a really good feel in there on the feelers for the slot width. And then I've used several sets of slips here, all made up, slip gauges, different slip piles, and I need to remind myself which ones are which, but largely I think that's the 2.1mm. I've used that to gauge the thickness of this slot. I've then used that in conjunction with another set of slips, which I think was this one, to actually then, this is going to be hard to show, to actually sit a slip in between and then use any old slip on top of that as a sliding slip, as you can see here, to measure the thickness of that end piece. And then I had another set of slips that I've used off the surface plate to measure this bottom relief at the bottom, so I kept building the slips up until I just got a feel under that shoulder. So I've used the best that I've got to measure that. Now when it comes to the angle itself, that's really quite difficult to do, so I've measured that 2 or 3 ways and double confirmed my dimensions each way. So the first way I did it was to measure using the clock here, and I took the highest reading before it runs into, there's a bit of a radius in the corner, so I took the highest reading, zeroed out on that, went down to this end, took the lowest reading just before it drops off, took the difference between those two readings. That gives me half the diameter difference, if you like, along that angle. And then I've used slit piles again to measure the length of that, and then I've done trigonometry calculations to measure the angle. Now fortunately, and what's apparent with this is it's German made, so it's metric, and I was expecting a round number for this angle, and I absolutely got a round number. I got to probably within 2-3 decimal places. I was getting 3 degrees included angle for that. So then what I did, very rough and ready, was I used my inclinometer on a parallel, and I just zeroed out on top of the V blocks like this, and then I sat the collet on top of that and dropped the inclinometer on top, and just double confirmed I was getting near about 3 degrees with the inclinometer, which I did. I got 3 degrees. It's a bit iffy, but it's all about giving yourself confidence that you've got it right. So I've pretty much taken all the dimensions I can on that. Now from a reverse engineering perspective, there's not, as I said, there's not a lot of thought processes behind this one, because every dimension is critical. So this needs to be machined really in one. Ideally it should be ground. That's not possible, well, not in my shop at the minute, but certainly in terms of for my subscriber, and I'm not quite sure what gear he's got in his shop, he may have the ability to be able to grind. So I'm going to dimension this up fully. I'm going to put kind of respective tolerances on that I think it needs to maintain concentricity and good clamping, and I'll be sending that off to my subscriber. I think I can use his name, that's Peter. So that'll be coming to you, Peter, shortly, once I've had time to make sense of, and I've done the usual thing, you know, I've done a very messy scratch pad drawing of all of the measurements that I've taken. I now need to go and turn that into a proper manufacturing drawing for you and for me, hopefully at some point in the future. So yeah, with all that, that's just some different ways of measuring stuff up, and I used those two examples largely because I needed to do it, as I said, but secondly because they're at complete opposite ends of the spectrum really, from a rough casting with only a couple of things that really matter on it, with all the thought trained processes that I've been through, to something like this that really you've got to measure it up, you've got to decide what tolerances you think this needs to have applied to it from a manufacturing perspective, and then you've just got to go for it, see what you can make and see whether it works. So as and when I do get into manufacturing these, because I can't buy them, and you know, the two choices I've got is try and make some collets or modify the entire spindle on the engraving machine to put a sort of ER11 or ER16 front end on it, which I don't really fancy doing. I'm going to have a crack at making some collets, I think, at some point in the future. So that's going to be a really interesting video, because these are really difficult and tiny things to have a go at. So with all that being said, I will go back to the board and we will close this episode out. So there we go guys, that gets us to the end of this workshop tips video. Bit of a tricky one this really, but it was, as I said at the start, necessity for me to do these couple of bits, and I've just thought, well, rather than me just do that and the next thing you see is me making some bits without any of the thought processes that have gone in behind that, nobody learns anything if we do it that way. So hopefully this has been helpful, certainly for the shaper bracket. You know, that's probably much more what somebody's going to be attacking in a home shop, something similar to that, and that's why I did a lot more around the thought processes sitting in behind that, and it was much easier to do that around that part. On the collet that you've just seen, much more difficult, you know, and what I may do in a future leather video or something, once I've drafted up that collet drawing, I'll show you what I finished up with and the tolerances that I've applied to it. I can't do that yet because it's raw. I've only just finished measuring it, so I need to go and draw all of that up, but I will show you my thinking in maybe a future video, just a quick look at it, just to show you what kind of tolerances I applied and why, and why that would be important when you're reverse engineering something. And again, it's a bit like the bracket. Thought processes around what's its final application, what does it mate with, you know, what are when it's built up into an assembly, which are the bits that are important, which are the bits that touch, which bits don't, which bits locate. It's the same kind of logic, and you need to be thinking about that when you're dimensioning up your drawing. Now, as I said, for the bracket I could do that live in the shop on a bit of paper, dead easy. For the collet, I'm going to need to go and do a proper drawing and give that a bit more thought and do that with a bit more rig around it. And obviously the collet, you know, I'm quite fortunate. I've got some good measurement gear in the shop. It's not the most ideal way to measure something like that. You know, even better measurement gear would be what you really need, maybe shadowgraphs and things like that for measuring some of the drops and the small radiuses and things. Very difficult to measure manually in a workshop on a surface table, but you know, I think the measurements I've taken will be good enough to replicate that collet. So if you've not got that kind of measurement gear, that would be a really difficult one. So, and I appreciate that not everybody has. So, but I hope you found it interesting anyway. I hope there's been some tips there, especially around the thought processes of you know, reverse engineering something, that it's not just a case of just taking a bunch of measurements and then going for nominal dimensions on everything, because 9 times out of 10 that's not going to work and you're going to have to end up doing some rework. So it's all about that thought process while you're doing the measurement and looking at the bigger picture where it all fits in, and thinking hard about the manufacturing processes, the materials, the way you're going to hold it, where you're going to datum it from, which datums are important, which surfaces are important, how that fits into a bigger assembly. You need all of that thought process going while you're dimensioning up to make sure that you get it right first time, or as close as you can to right first time. So as I said, I hope that was a bit interesting, something a little bit different, and thank you to the subscribers and the new subscribers that are coming along, and we will catch you all very soon on another video when we'll be making something else.